and with the help of convex lens I shall try to derive lens formula. Let us develop the class. This content has been prepared by Anand Prazapati with the help of Join for Education. This is a convex lens. Consider about this convex lens. This is the principal axis of the convex lens passes through the optical center O. This is the optical center O of the convex lens. An object AB is placed on the principal axis of the convex lens. AM is parallel to the principal axis of the convex lens and incident at M. After the refraction, it will passes through main focus of the convex lens. This is another ray of light passes through the optical center of the convex lens and intersect each other at A dash. So, A dash B dash is the image of the object AB. So, consider about a convex lens, an object AB, that is the AB, placed on the principal axis. This is the principal axis. After refraction, the image A dash B dash, this is the A dash B dash, formed on the principal axis. Consider about this figure. From figure it is clear that OB is the object distance, O dash B dash is the image distance, OB is the object distance and it is generally denoted by U. According to the coordinate sign convention, OB will be minus U and OB dash will be V. F is the main focus of the convex lens, therefore, OF will be the focal length and it is generally denoted by F. If we consider about B dash F, then this one will be OB dash minus OF, it means that V minus F. So, B dash F is the V minus F. From figure it is clear that OB is the object distance equal to minus U, OB dash is the image distance equal to V, OF equal to focal length equal to F and AB equal to MO. From figure it is clear that AB equal to MO. Consider about the triangle ABO and A dash B dash O. These two triangles are similar triangle. Vertically opposite angles are equal. This is right angle, this is right angle, this is the remain angle and this is the remain angle. So, triangle ABO and A dash B dash O are the similar triangle, therefore, ratio of the corresponding sides will be equal. So, AB by A dash B dash equal to OB OB by OB dash. This is the equation number 1. Let us develop the class. Now, consider about the triangle MOF. This is MOF and A dash B dash F, A dash B dash F. These two triangles are also similar. This is the vertically opposite angle, this is the right angle, this is the right angle, this is the Riemann angle, and this is the Riemann angle. Therefore, corresponding sides will be, ratio of the corresponding sides will be equal. Therefore, MO by A dash B dash equal to OF by B dash F. So, from equation number 1 and 2, left hand side are equal, therefore, right hand side will be equal. So, the next step will be, now from 1 and 2, next step will be OB by OB dash equal to OF by B dash F. So, OB equal to minus u according to the coordinate sign convention. This is the object distance, and OB dash is the image distance according to the coordinate sign convention. This one will be V, and OF is the focal length and it is equal to the F, and B dash F equal to OB dash minus OF. OB dash equal to V, this is the V, and OF equal to F or focal length, this is the F. Now, by cross multiplication, minus plus minus, this is the minus UV, minus minus plus, this is plus UF, and equal to V into F equal to VF. So, we move minus UV in the right hand side, therefore, this one will be plus UV, and VF move in the left hand side, therefore, plus VF will be minus VF. Now, this one is divided both sides by UVF. Now, dividing both sides by UVF, then UF divided by UVF, then we get 1 by V, this is the minus, we write down here minus, VF divided by UVF, then we get 1 by U equal to UV divided by UVF, then we get 1 by F. So, this is the last step, or this is the Lenz's formula, 1 by V minus 1 by U equal to 1 by F.